Hello everyone, my name is Yong Hong. Today I'm going to present the calling behavior of the blue whales and fin whales in relation to environmental conditions. First, why we choose the coast of South Africa as my place. First reason, the coast of South Africa didn't have the record of Antarctic blue whales and fin whales. The second reason is there are no evidence to prove this place is the migration route of these whales. And this paper has three main targets and 2 point species. First target is to recall the acoustic data of Antarctic blue whales and fin whales in the coast of South Africa. And second is to prove the coast of South Africa is the migration route of these whales. Third is to know the relationship between the environment and whales. And the 2 point species is Antarctic blue whales and fin whales. And why we use the hydrophone rather than just watching. The benefit of the hydrophone is it won't miss the whales under the water. And second benefit is it can reduce the cost. And third is it can recur for a long time period. And what is fourth? It takes time to analyze the data. And there might be some accident to the hydrophone. It might be destroyed by ship or boat, and it might be disappeared. And this is Antarctic blue whales. Antarctic blue whales have two types of calling, Z-calls and D-calls. Z-calls is used to group communicate, and D-calls is used to long distance contact. This figure is called spectrogram. And the x-axis is time, and y-axis is the frequency, and the z-axis is the sunfration level. As its name, Z-calls has Z shape on the spectrogram, and this is the D-calls on the spectrogram. And this is the fin whales. Fin whales also have two types of calling. It calling at two different frequencies. And the higher frequency is about 140 Hz, and the lower frequency is about 40 Hz. And how do we get the data? We use the mooring and underwater hydrophone to record the acoustic data. We put the two mooring with two underwater hydrophone at two different places. In this paper, we call these places from AAR1 and AAR2. And where do we get the data? This is the red point is the place we put the hydrophone, and the blue point is the Cape Town. Cape Town is one capital of the South Africa, and this country is South Africa. And the blue point is AR1, and the orange point is AR2. This is the latitude and longitude for AR1 and AR2. And for AR1, the hydrophone is being put at the depth 20 meters below the sea surface. And it's recurred from 2014, July 24 to December 1. And the total recording hour is about 600 hours. And for AR2, the hydrophone is being put at the 30 meters below the sea surface, and it's recurred from 2014, September 16 to 2015, December 1. And the total recording hour is about 3,500 hours. And this is the method in this research. First is XBAT. It's used to automatically find the whale course. And second is Bell-Hub model. The purpose of this method is to count the hydrophone receiving distance. And last is the random forest model. It is used to find the relationship between the whale course and the environmental conditions. And this is the signal we detected in this research on spectrogram. For the green one is the D course of the blue whales, and the red one, and the blue one is the Z course of the blue whales, and the red one is the fin whales low frequency course, and for the orange one is the fin whales high frequency course. And this is the environmental and time variables we used in this research. For first is sea surface temperature, wind speed, sea surface height, months, chlorophyll A, wind stress curve, and Ekman upwelling index. And as the cost, we can put many instruments to measure these environmental variables. So we use other institutes have been measured in this place. First, the sea surface is measured by OSTRA, and the chlorophyll A is measured by this organization in France. And the wind speed is measured by National Climatic Data Center. And for the wind stress current and Ekman upwelling index is measured by this institute in the States. And for sea surface height, it's measured by this institute. And as we know, the hydrophone receiving distance may change according to the temperature, season, even day and night. If the well coast inside the orange circles, the hydrophone in AR1 can receive the sound all year. And if it costs between the orange circle and purple circle, it might be received by AR1 sometimes. But if the well costs outside the purple circles, it can be received by AR1 the whole year. For this figure, the minimum hydrophone receiving distance is 20 km, and the maximum hydrophone receiving distance is 50 km. And for AR2, the minimum hydrophone receiving distance is increased to 35 km, and for the maximum hydrophone receiving distance is about 60 km. And how many cost occurrence in the two different places? For AR1, it record total time is 6,100 hours. And for AR2, the total recording time is 3,500 hours. And we split the time of AR1 with every 30 minutes and split the time of AR2 with every 20 minutes. For example, in AR1, for example, if we found 10 seconds well course in these 30 minutes, we count this part of time 30 minutes all have well course. So this is how we count these numbers. So in this condition, our target is to solve if this part of time have the well course occurrence. So in AR1, the pink well course is about 14 hours. And for AR2, it's about 211 hours. And for AR1, the blue well course is about 80 hours. And for AR2, it's about 156 hours. And how many course occurrence in the two different places? For AR1, we detect blue well Z course about 2,600 times. And for AR2, it's about 6,100 times. And we don't detect any blue whale decoys in AR1, but in AR2, we detect about 176 times in AR2. And for pink whales in AR1, we detect about 2,500 times in AR1, and for AR2, the number increased to 54,000 times. And as this figure shows, the x-axis is a date, the y-axis is a proportion of occurrence. The blue bar is a blue whale in AR1, the red bar is the pink whale in AR1, and the black bar is the pink whale in AR2, and the green bar is the pink whale, is a blue whale in AR2. So as this figure shows, we can roughly say that there are nearly no whales from October to April. So in summer, it might be migration to another place, but in winter it might migrate to this place again. And this is the relationship between the environment and the whales. The x-axis is the relative importance. Relative importance is one statistical factor. It is used to let us know what is the most important thing for the blue whales. And for these figures, this is all the important factor to blue whales in AR1 and AR2. But as we know, months is the most important thing to the blue whales in AR1 and AR2. This makes sense because in this figure shows the months, it does play the important role. And for this figure, you can know that the month also plays the most important role in big wells in AR2. But in AR1, EU Ekman upwelling index is a top factor. And how does the environment impact the blue wells? And months, high UI, high SSH, low SST, low wind speed, and low chlorophyll A causes high rate of blue wells. And months, high UI, high SST, low wind speed, low chlorophyll A cause high rate of fin well cause. And what's the important factor to the wells and why? Months plays the most important role in the wells, because the wells will migrate to another places. And UI, SSH, wind speed, chlorophyll A also plays an important role. And does it make sense? Yes. The wells are often reliant on upwelling regions. And this variable is always used to describe upwelling events. This flow variable is always to describe the upwelling events. And does the research arrive at the target? Yes. First, it provides a record of the acoustic data of Antarctic blue wells and fin wells in this place. And second, it proved the coast of South Africa is the migration route of these wells. Last, it let us know the relation between the environment and wells. And does this research have another discovery? Yes. The wells we previously thought fit in the Antarctic or lower longitude during winter. In this research, we found decals in this place. Decals is always associated with feeding, so it means the wells might feed here. And last, it provides the evidence that well feeding might be in relation to seasonal environmental change. Thanks for listening.
In this book, I think there are many details in our paper, and you speak very well and you speak very clearly. We can know what did you say. And you put many details in a picture, and it is easy to let us know what did you talk about.
I think that you speak slowly enough in your first presentation and have a well explained to your image. But the word is too many that I got a little bit to follow. Hard to follow.
Okay.
Let's talk about your advantage. And the table is well guided, and the pros and cons slide is very clear and impressive to me. And second, you talk smoothly and calmly. But your disadvantage is you did not look at audience. You just take a pointer and you don't look at audience. And I think some slide is unnecessary for the presentation. Some data is unnecessary. Like where the data are measured, I think it is not important.